Hello, Chem One. Hopefully, everyone is having a great time off. Um, I know it's been like almost 4 weeks now since we have met. As a matter of fact, today is April 13th as I'm taping this, and the last time I saw you was March 13th, so it's been a month. Today is going to be the first of 3 videos for this week that I am going to create about chemical reaction types. And then there's also going to be a bunch of videos that I'm putting on OneNote for you to use that are more professionally created than mine. But I wanted to make sure that I had a chance to at least give a little bit of my twist on the types of reactions and how maybe to predict products. So the objective for today and tomorrow, the next 3 videos, is to be able to recognize types of reaction and to be able to predict products of a chemical reaction. We are not going to focus on balancing equations at this point. That will be the next thing we'll do after we deal with the types of reactions and be able to just predict products, see what's there, then we'll worry about balancing them. So occasionally you may see some things that might bug you a little bit, and I'll bring those to your attention about things that don't seem to be quite as kosher as it could be. So we'll see how that goes. So what is a chemical reaction? Well, chemical reaction is one in which one or more substances will chemically change into completely different substances. The chemical reaction is one where you are definitely going to have a new substance, a new compound, a new different elements, whatever, that are going to be created. We're not going to change the elements involved. We're just going to change the bonding that takes place between those elements. And the physical change is going to be accompanying the chemical change. So we're going to see some differences, whether we look at color changes or we see physical changes, going from a liquid to a solid, and maybe the gases are going to react and you're going to get a solid in the end. So there's going to be something there that's going to show that a chemical change has taken place. The things that most normally are associated with a chemical change are, like I said, there's the color change. There's also heat being released. Normally, whenever there's heat being released during a reaction, that also is indicative of a chemical change. Maybe light, maybe some type of movement, a work being done, some movement of the space around the molecules are usually the things that you're looking for. But color change is a biggie, and phase change, phase creation is a biggie also. So what's it look like? Well, you're going to have things that are the reactants, and that in this case would be sodium and chlorine. And there's going to be some material that is going to be called the products. So whatever you start with in a chemical reaction are called the reactants, and whatever you end up with are called the products. The thing that has been produced, the thing that has been produced, or the things that have been produced, or the products. And then there's an arrow put in between, an arrow indicating from the reactants to the products, from left to right, indicating the chemical reaction has taken place. We normally write it in a symbol form. So sodium and chlorine. Sodium is Na, chlorine is Cl2, and the product is going to be sodium chloride or salt, NaCl. So Na and Cl2 are the reactants, and NaCl is the products. And again, there's that arrow in between. Now, one of these components, this chlorine, the Cl2, has a subscript 2 after it, whereas all the other elements tend to not. Well, chlorine has a 2 because it's a diatomic element, di meaning 2, atom meaning this compound or this element only exists in its natural state as an element in pairs. It does not exist in nature by itself. You would not find a Cl atom by itself. Cl atom would find another Cl atom and form Cl2, the molecule. There are 7 diatomic elements, and they're normally remembered by the acronym or the quirky little term of Brinkelhoff, B-R-I-N-C-L-H-O-F, Brinkelhoff. Stands for bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. Those 7 elements are diatomic when written. Okay, so there are 4 major types of chemical reactions, and you guys all last week did the POGL that focused on these 4. I'm going to go ahead and in this video we're going to talk about synthesis and decomposition, and then there's going to be 2 separate videos associated with single replacement and double replacement, because both of those have a unique way of determining whether or not the reactions will take place. 3, 2, 1. So the first type of reaction is called a synthesis reaction. And a synthesis reaction is one where you have a combination of two or more substances, usually their elements, being combined together to form a bigger, larger substance, obviously a compound. So you're going to have two or more reactants coming together to make a larger substance, a compound or a product. You can always tell this is a type of synthesis reaction because you're only going to have one product. You may have 2, 3, 4, 5, a whole lot of reactants, but there will be just one product. You're synthesizing that one product. Basically, if you look at it from a perspective of just symbols, A plus B gives you AB. Okay, whatever A is, whatever B is, it doesn't matter. They're two different elements. They're coming together to make whatever compound happens to bring them together in an AB combination. So example might be potassium plus chlorine giving you potassium chloride. Now this equation has been balanced to make sure all the elements are okay. You notice you have 2 Ks on both sides and 2 Cls. We will focus on how to do that in a later episode of these videos. So here is a reaction between potassium and chlorine. Potassium is a metal. It's in this small thing. It's underneath, in this case, it's in a container of mineral oil because it reacts very, very aggressively with oxygen in the air. And this is chlorine gas. And then you make potassium chloride, which is a white salt. I have a weird video that I'm borrowing here from YouTube, and we're going to see how easily this connects over. So I click this little icon up here. Here's a reaction that happens to be just between sodium and chlorine, very similar to the one between potassium chlorine on the previous visual. This is a blurry image, but at least it shows the reaction between the element sodium and the element chlorine together. Let's watch the video.
A small piece of sodium metal is placed in a flask containing yellow chlorine gas. The flask also contains sand to prevent the heat which will be generated by the reaction from cracking the glass. Initially, no reaction is observed between the sodium and the chlorine. The reaction will be initiated by adding a drop of water to the sodium.
Shows a reaction between elemental sodium and elemental chlorine to make the sodium chloride molecule. Okay, so let's look at other reactions. If magnesium were to react with chlorine, what would it make? So first thing you need to do in order to write a reaction for a synthesis is write the reactants symbols. So magnesium is Mg, chlorine, because it's Brinkelhoff, is Cl2, is going to create the substance of magnesium chloride. Magnesium has a +2 charge and chloride has a -1 charge. So remembering to do the crisscross, putting the magnesium first and the chloride second, and crisscrossing the elements, we get MgCl2. So our product is going to be MgCl2. And again, you can tell that this is a synthesis because you only have one product. So let's try this. Calcium and sulfur, what would its reaction be? Go ahead and pause the video for a second, and we'll go ahead and come back and see how you did. Let's see how you did. So calcium and sulfur. Calcium is Ca, sulfur is S. Neither one of them are diatomic, so they're written just as their elemental form. Yields, well, calcium becomes +2, sulfide becomes -2, and CaS. Let's try another one. Potassium and oxygen. I'm going to ask you to pause the video and try this one when you're in also. Let's see how you did. So potassium is K, and oxygen is O, but oxygen is diatomic, so it's O2. Potassium, the ion, is +1. Oxygen, the ion or oxide, is -2, so the compound is K2O. Now, notice that this is not balanced. There's 2 potassiums on this side, and there's only 1 on this side. There's 2 oxygens on this side, but only 1 on this side. We'll worry about balancing that in a future episode. But for this, I want you to be able to determine what the products would be and what from the reactants that are given. The next type of reaction is a decomposition. And you can tell a decomposition reaction by the fact that you have a reactant, a single reactant, breaking down to form multiple products. Normally what you would have is your reactants breaking down into its elemental form, all of the elements. So the reactant, as far as predicting products, I would want is the reactant would be a compound, a single substance, and your products would be each of the elements. So in general, it is the opposite of a synthesis, AB becoming A and B. If you look at this example, mercury oxide would become mercury and oxygen. And don't forget to use your diatomic elements for the Brinkelhoffs. So a reaction that they're just referring to in the last example was mercury oxide breaking down to make mercury the metal and oxygen gas, the fizzy at the top, because that happens when they heat that mercury oxide up. Normally for a decomposition you have to break the bonds, so you normally have to add some heat to it to break it down. Now there are some exceptions on how decompositions take place. One of the exceptions is with carbonates and one is with chlorates. Now for everything except for carbonates and chlorates, I want you to be able to predict that the products are going to be just the elements. But if you have a carbonate as one of your reactants, what's going to happen is carbonates are going to break down to give you carbon dioxide and a metal oxide. Okay? So for instance, calcium carbonate, when you decompose calcium carbonate, it's going to make carbon dioxide as one of your products, and the other product is going to be the metal plus the remaining oxygen. Now this metal oxide, sometimes you're going to have to balance it out because the oxide is always going to be -2, but your metal might not always be +2. But you're going to have to balance that out. But you're always going to make carbon dioxide and a metal oxide. Second type is a chlorate. Now that was a little more interesting. Chlorates are ClO3. So anytime you have a metal with a chlorate, you're going to create oxygen gas and then a metal chloride. So the chlorine is going to bond up with the metal, and the oxygens are going to combine, or going to just combine together in diatomic form. So example, if I had aluminum chlorate, and this is the formula for aluminum chlorate, it's going to make aluminum chloride, and then oxygen gas. And however many oxygens there are, again, we're not worried about balancing at this point, but you're going to make oxygen gas. These are the only 2 exceptions I want you to remember. There are quite a few more as you get further and further along in understanding of the chemistry reactions. This becomes a little more complicated, but for right now, decompositions break down into its elements with the exception of carbonates or chlorates. So let's practice. So lead 4 oxide decomposes. What's that going to make? Lead 4 oxide. Well, it's going to make lead, and then it's going to make oxygen. That's it. Breaking down into its elements. What about this? Sodium carbonate decomposing. So again, we know we're decomposition because 2 reasons. One, it says decomposes, but secondly is it has just one reactant. So we're going to take our sodium carbonate. We see the word carbonate, so we know it's going to be special. And we're going to take our sodium carbonate and write that. And then we're going to make carbon dioxide and the metal oxide. Again, this is one where since sodium is +1 and oxygen is -2, we had to do a little balancing of the reaction. Last example, sodium chlorate. If sodium chlorate were to decompose, again, chlorate is one of those exceptions. So we have to do something a little special, a little different than the just breaking down to its elements. Sodium chlorate is going to break into sodium chloride and oxygen, the gas. Remember, chlorates break down into metal chlorides and oxygen gas, whereas carbonates break down into metal oxides and carbon dioxide. make sure you memorize those two exceptions. Carbonates and chlorates are a little different than everything else. So what's next? The next video is going to focus on single replacement reactions and how to use what's called the activity series. It's going to be a whole separate video, probably about the same thing, 15, 20 minutes long, that is going to describe how to use the activity series. Be safe, be healthy. Please practice your social distancing, and I'll see you in the next video.